Hello, this is Laura Wogozogan, your math instructor for this semester. This is a video that's going to look over project number 4, which is over M&Ms. So the first thing is in modules, you'll notice at the bottom there'll be a project number 4 module. And this has in there the M&M project PDF. It's written as a PDF, and then right underneath it, it's also written as a Word document. Likewise, you'll notice a data roster with a PDF version and then also as an Excel. Below that will be where you would turn in your project. And so going ahead and looking at our project PDF first, we're going to go ahead and the beginning part will be just an introduction with M&Ms, and so you can read that, a little historical information. What we're going to have is every student is going to get a virtual bag of M&Ms, and we need to use that virtual bag of M&Ms and the class data set of all of our bags of M&Ms and status to complete this project. So the objective is listed here. The big part here to notice is that the project does need to be typed, just like all the other projects have had to be typed, and completed in order. So show all work for any calculations, such as outliers and z-scores or any other calculations that arise throughout the project. It says upload your completed project as a single PDF file. Right below this is the color distribution of plain M&Ms stated by the company. So you'll notice 24% blue, 13% brown, and so forth for all other colors. After this, you'll notice that everything's going to be labeled with activities, and next to that we'll have the points value for that part of the project. And so activity 1 says, record the number of M&Ms by color for your bag, and then record the class totals. Use all data values found in the M&M data sheet. So if you go back to our module, you'll see the data sheet that's on there, the data roster, and I'm going to go ahead and select the PDF, but you can also use the Excel sheet. And with that, it's going to go ahead and open this up, and you'll notice that at the top it's going to say last name, and then it have the color and then totals. So this is going to be every student is listed on here. I did include myself in our data set, so make sure to include my bag of M&Ms in addition to all your other classmates. So Wogozogan, my last name, is listed on here, and you'll notice that underneath Wogozogan is all the other last names, and so you'll need to make sure you find your last name. If for some reason it's not listed, please reach out to me as soon as possible. So on here, you'll notice that in my bag of M&Ms, there's 19 blue M&Ms, 5 brown, 5 green, and so forth, with a total number of M&Ms in my bag being 58. So if you scroll, you'll notice that this is all of the students in our class, and at the very, very end of this, you'll notice that this says total, and those are blank. So in order to get those totals, you do need to add up the columns to get the total number of blue M&Ms, the total number of brown M&Ms, total number of green, orange, red, yellow, and total M&Ms that we have among all students. And so this is where you will find your bag. Again, next to your last name is going to be your bag of M&Ms. So going back and looking at our project, it is going to ask for activity 1 for you to write down the totals that you have for your bag of M&Ms. You need to make sure that you use the data that is provided in your virtual bag. Do not pick a different virtual bag to use. I will be checking names and bags of M&Ms that you were given to make sure that your calculations are correct. So your bag, any questions at all with that, please email or visit me during office hours. And then those totals you need to put on here for blue, brown, green, orange, and so forth. Those will be rather large numbers. Activity 2, it says, this is 4 points. It says calculate the sample proportion for each color of M&Ms for your bag and the class data. Round 3 decimal places. So make sure that you read the questions and follow the directions. It does tell you how to round in this problem. So the sample proportions for me, my bag, I had 19 blue M&Ms with a total of 58 M&Ms. And so to get my proportion, I would have to take the number of blue M&Ms, which for me was 19, and divide by the total M&Ms in my bag, which is 58. I can do that on my calculator. Getting that answer, I'm going to round it 3 decimal places. Likewise, I would do the same thing for brown. I had 5 brown in my bag, divided by that 58 total, get my decimal approximation, rounded 3 decimal places, and type that in. Likewise, I'm going to do the same thing for the class, using those totals from number 1, activity 1. So those numbers that you're using would be rather large. So your bag is going to be unique for you, but the class proportions that we have would be the same for all students. The next activity that we have is worth 4 points. This is activity 3. This has to find the probability of the problems below. Use class data. This means you're using those larger data values to do your calculations. Make sure to show clear steps and all work, no credit. Round 4 decimal places. So for this one, it is telling you to round 4 decimal places. It's been a while since we've done probabilities. So if you're not remembering this all, it's a good idea to go back and look at our chapter 4 notes. So make sure you go back and look at the probabilities. The next part that we have says for activity 4 through activity 10, you must include screenshots of output from StatDisk. If no StatDisk computer output is provided, then no credit will be given for that part. In addition, don't forget to state the null and the alternative hypotheses, conduct the test, and state a clear conclusion for all hypothesis testing problems, as done in our class notes. So make sure the wording is the same as what we've been using for our homework and our class notes. All p-values need to be rounded 4 decimal places. Confidence intervals need to be rounded 3 decimal places, and your interpretation should be done like they are done in our class notes. So activity 4 and activity 5 are actually things that we've seen before on previous projects. So with activity 4, it's 5 points. This is for the class data. So again, using those larger values, find the 5-number summary, sample mean and sample standard deviation of blue M&Ms. So these are our descriptive statistics. We've done this on all of our projects so far. So definitely go back and look at your past projects if you forgot what you need to do. It does tell you to round 3 decimal places also for activity 4. Activity 5 says use the mean and the standard deviation from activity 4. What percent of bags of M&Ms have more blue M&Ms than your bag? Assume the number of blue M&Ms per bag is normally distributed. Round 3 decimal places. We've done this on previous projects. Project number 2, we did do this also. So this is a normally distributed problem. So if you think about it as a normal curve, for this, you do need to calculate your z-score. Make sure you show your work for your calculations. The next one that we have is activity 6. And activity 6 says using the class data, so again those large values, test the claim that the true proportion of blue M&M candies is 0.24 at the 0.05 significance level. So this is now new stuff. And so for this, we'll take a look at StatDisk in just a moment. And also for the directions up above, it does say to make sure you state your null and alternative hypotheses. So H0 and H1. It does say in the problem proportions, and we are talking about blue M&M, so this is just one proportion that we're looking at here. 0.05 significance level, so we will have to get that p-value, conduct our test, and then write the correct conclusion like we did in our notes. So again, we will look at StatDisk in a moment, but activity 7 says to create a 95% confidence interval for the proportion of blue M&Ms using the class data and interpret your results. So this time we're doing a confidence interval. Make sure that you interpret your results. And again, we're doing the confidence interval for the proportion of blue M&Ms. Those keywords there are proportion, or like we'll see later on, the mean. Activity 8 says to use the data from the class to test whether the proportion of brown M&Ms is different than the proportion of red M&Ms at the alpha equals 0.05 level of significance. Assume independence. This time we're also doing a hypothesis test with proportions, the keyword in here, proportions. But this time instead of just one color of M&Ms, we have 2 colors. So we have 2 groups. So we have brown M&Ms and we also have red M&Ms. Activity 9 says how many M&M candies should be sampled to obtain a 95% confidence interval of the proportion, which is another keyword, of blue candies with a 4% margin of error if the prior estimate to blue M&M candies is 0.24. This time we're asked to find our sample size. Then we have activity 10, which says the Mars Company claims that plain M&M candies are distributed with the following color percentages, and they're all listed there. It says test the claim that the color distribution is as claimed by the Mars Company using the data from your bag of M&Ms. Use the 0.05 significance level, and it says include a table of both your observed counts and expected counts for your bag of M&Ms. We did a problem very similar to this in our chapter 11 notes. It dealt with, instead of plain M&Ms, it was with peanut M&Ms. So definitely a good example to go back and look at. That was using that goodness of fit test. So these are all of the parts that we have on here. Again, remembering that activity 4 through activity 10 do need to include screenshots. If you do not put a screenshot in for that activity, it will be 0 points. So I'm going to go ahead and look at StatDisk. And so with StatDisk, the first thing you'll notice is that was a lot of data. There's a couple ways to get the data onto StatDisk. One, you can upload the data and choose a file if you were to save it on your computer. Or it works for, I would say, a good half of the students, is that if you were just to copy that data and go into StatDisk and just paste it in there, a lot of times it will just load. It does depend on the device that you're using if that feature will work. If not, save it and then again upload your data. So we had, for new parts for this project, if you go to analysis, we had a couple questions that did ask about hypothesis testing. So the wording is pretty straightforward on StatDisk. They do use the wording hypothesis testing. When you select that, you need to understand what type of test it is that we're doing. So proportions, was there one sample or one color? Or was it proportions with two samples, or for ours, two colors? We have mean one sample, mean two samples that are independent, or match pairs data. This is going to be where they are dependent on each other. The standard deviation ones we do not use for this class. Likewise, for the confidence intervals, it's set up identically to what the hypothesis testing was. So you would have to know what the problem is asking for and you select the correct one. So for example, if you were to select, I'm just going to select one to look at, but mean two independent samples. Selecting this, you can use data. And since we imported all of our data in, you would just have to select where that data was located. Right now, I currently don't have any data in, but your confidence level gets typed in. Population standard deviation, we do not know that for our problem. And then once you have that, you would just go ahead and hit evaluate down at the bottom. And then so that's for confidence intervals. The same thing is for hypothesis testing. Again, if you were to select one of these, it's going to be down here is going to be a drop down with what your alternative hypothesis is, your significance level, your claim proportion for this one, sample size, and number of successes. So it's set up very similar to what we have for our graphing calculator. And so with that said, there was a few other problems. One was asking about sample size. So you'll notice that, again, the wording is very nice on StatDisk. It does say sample size determination. So you have to read the problem and understand, is it a problem that deals with proportion, or is it a problem dealing with mean? And then selecting that and then putting in your information. And likewise, we also had our last question on our project was asking about the goodness of fit. There are two options here. So one is equal expected frequencies and one is unequal expected frequencies. Those colors that we have for M&Ms all have different percentages, so you would definitely need to be selecting the unequal expected frequencies. And then doing that, you're going to have to make a new table with your observed counts and then your expected counts, just like how we did in our class notes. It does say you want to select them as counts and make sure that your significance level is set. Then evaluate. So hopefully this answers all of your questions with this, but again, things do come up with the project. So if there is any questions at all, We have a lot of resources. One, you can always email me or stop by my office hours. Those are listed on our syllabus. You are also able to use any of the free resources that are on campus. One of the best ones to use is our Marks tutoring service, which is free. They have a computer lab and a full-time instructor that's in there that can help with this. Do not procrastinate. This is your last project for the semester, and you want to make sure that you do the best that you can on this. Best of luck, and please let me know if there's any questions.